Hello everyone, welcome to the next video of the lab 1 part 3. So in this video, now we will start updating the code of the part 2 to meet the deliverables of the part 3. So I'll first save this project as a separate project. The project save as. So this is the lab 1 part 3. So in the new this part 3, we need to update the definition of the your module, top module, because now we will have the additional input. So we will have the one push button to increment the minute value. So this is push button to increase minutes. Then we will have another push button to decrease the minute value. Then we will use switch to decide when to increment and decrement the push button to decrement the minute value. Minutes. Okay. There is no change in the output because we are going to use the 7-segment display on the board as well as on the PMOD. Okay. So the next thing we need to take care is that we need to do the push button debounce. For that, we need to generate a corresponding the clock between 200 and 250 hertz. So as we know, we are getting the clock of around 8.388 megahertz from our clock IP, and then we will modify that clock to get the our 220 hertz. So we will add the additional task. So we can say task 2.1 generates a 250 hertz clock from clock 8 megahertz. So say 250, and so this input will remain the same. The output is clock out is 250 hertz, and if you do the calculation like we did in the last time, the number will come around to 40. So 8 megahertz divided by 2 to the power 14 plus 1, you will get the around 250 hertz of clock. Okay, so now we have generated the clock. Now we need to add the push button debounce circuit. Okay, so this is the task, we can say 6, 7, 9, so we can say 10. So we can say 11, and I'll modify this task as to 10. So task 11 is to add push button debounce circuit. Okay, so this is my task 11. In that, I'll add the push button debounce circuit. And as we discussed, this push button debounce circuit will generate a 1 clock pulse for the pressing of push button. Okay, here we have the 2 push button. So we will design the circuit such that if any of the push button is pressed, it will generate a clock pulse. Okay, so we will have the one output of this clock pulse, which is the clock change, which will go to 0 to 1 for 1 clock cycle whenever there is a push of a push button. So clock dep pulse. Okay, so this is my circuit. Then you have the clock 250 hertz, which is the input of this circuit. Okay, then you have the two push buttons to detect whether there is a change in the any one of the push buttons. Then there is this next push buttons. Okay, and the output will be the this clock pulse, which indicate that any one of the push button has been pressed. Okay, so now let's look at the logic of this circuit. So we need to write a new Verilog file for that. Okay, so that is clock 250 hertz. That is the input, and CRPP, that is also input, DCRPP, that is also input, and clock change, that is the output. Okay, so the logic we have already discussed about this circuit. Only difference between the logic we discussed in the slide and here is that there are two push buttons. So we need to detect either one of the push button. So what we will do is that we'll use one internal variable that indicate that any of the input is changing. Okay, so it's a combined input of the push buttons where we will do the OR of operation between the two push buttons. Okay, so instead of combine this one, you can always combine in a line, but it is always better to write properly. Okay, so this is the one which will check which any of the push button is changed. Then as required, we will have the three flip-flops. So we'll define the output of the each flip-flop, FF1, FF2, FF3, reg, FF1 next, FF2 next, FF3 next. So then always at was age of my clock, which is 250 hertz. So we need to see if the push button remains high for 350, three clock cycles of the 250 hertz. So FF1 reg next. So this is the third one. And then the output of the first input of the first uh, flip-flop is my push button input. Okay, then input of my second flip-flop is my output of the first flip-flop. So it should be the FF1 bridge. Okay, so the output of the first flip-flop is the input of the second flip-flop, and the same thing, input of the third flip-flop is the output of the second flip-flop. And then the final output, which is the assigned clock change, is the output of the first flip-flop and read with the output of the second flip-flop and the third flip-flop, which is the inverted one to get the clock edge. Okay, so with this we have completed the push button dip-down circuit, and at the output we'll get this clock change 1, which will go to the 1 for 1 clock cycle whenever one of the push button is pressed. Okay, so in the next video we will discuss how we can use this clock change along with the decrement and increment to set the minutes counter.